Hello, statistics student. This video is to show you how to use the online normal calculator to find probability of X bar, as well as which is as a mean of X, as well as probability of um, sum of X. We call it sigma X. Use this small symbol. So X bar is the mean of X of a sample. So basically, you collect a sample from X, like a whole bunch of X, and then you find the mean, and you want to find what is the chance of you getting this X bar for a certain range of value. You also want to find the probability that after you get a sample, if you add all those X together, the sum of them, what is the chance of getting a sum of a certain value? So you would use the online statbook calculator to do it. The online statbook calculator can be accessed online from any browser. There's no need to sign up for anything. You just need to Google it. And here is the actual URL. But if you don't want to type the old URL, you can just search online statbook and then normal calculator. And the one that has show up as onlinestatbook.com, calculators, normal distribution, that's the one that you should get. And this is how the calculator look like. We use it to find probability of X before in chapter 6, where you would find the mean of, you would input the mean and the standard deviation of X. Just put whatever number that is given. And then you would involve the calculator, select the calculator option to help you find when X value is above, below, between, or outside a certain value. Except we are not using it to find X probability. We're using it to find X bar as well as sum of X. So to do that, we do not enter the mean and standard deviation of X here. We will have to make some adjustment based on central limit theorem. Central limit theorem tells us that if certain criteria are satisfied, X bar will be normally distributed. And if they're normally distributed, the mean would be the same as the old mean of X, but the standard deviation would be this one, would be sigma over square root n. What is sigma? Sigma is the old standard deviation of X itself, and then n is the sample size. Sample size is n. So you would have to adjust the standard deviation to sigma over square root n. And because you can't enter square root in the online statbook calculator here, they only accept a number. So what you need to do is you have to calculate this number and then use at least 5 decimal places to enter it. Once you enter this, then you can use the calculator to find X is greater than a number, less than a number, in between two number, or outside two number. So there are 4 options that you can find probability for. But before you involve any of these, you have to set this up. So these 4 examples that I have from A to D is to find probability of X bar. So you can see that it is X bar, which is the sample mean of X, greater, less than, in between, or outside two number. And all of them has the mean of X and sigma of X given as 115. So this is all, mean of X, standard deviation of X, they're all 115. So we would have to set them once, and then we can do the 4 example at the same time. So I'm just going to put this in. So when I say mean, so don't be confused that this is the mean of X bar. They will not give you the mean of X bar. You have to calculate it. So the first thing you need to do is calculate mean of X bar, and which is, we say, central limit theorem say it's just the same as the old one. But then the standard deviation of X bar would be 15 divided by square root of 32. So what is it? It would be approximately, let's use a decimal scientific calculator. 15 was the old standard deviation, and then we did square root 32. And then the answer will show up here as 2.65165. Write it down. 2.65165. Now this is valid for all of these. So because in example B, C, D, they use the same, they have the same mean of x and mean of the sigma of x. So we'll use the same thing again and again. So now to find probability of x bar is greater than 102, we will set this up and then use above, right? Set above and then do recalculate and get the answer. So first of all, let's get to the calculator. We set the mean to 100. And then earlier we calculate that to be 2.65165, which is 15 over square root of 32. It would be nice if we can just enter 15 over square root of 32, but they don't allow that. And then we want it to be above 102. So this is 102. You can see that 100 is still in the middle, and this is 2.65 for one standard deviation. And the probability is here, after we hit recalculate, is 2254. Oh, yeah, so this mean use above, you go to 0.2254. And then for probability of x bar less than 93, we remember that we have to set mu of x bar equal to 100, sigma of x bar equal to 2.65165 after we calculate 15 over square root 2. So probability of x bar is less than 93 would equal to use below. And the answer is, so let's say below. And then we type 93 here. We calculate 0.0041. There's very, very small chance of getting the mean to be that low, 0.0041. You can look at it, it's really small. The area is really small. And then the last two would be in between 98 and 102 and outside 98 and 102. So we would remember to set x bar equal to 100, the mean, and sigma of x bar is 2.65165. Probability of x bar is between 98 and 102 is equal to use the between option, right? It's very intuitive. And then we'll click between, we'll say 98 to 102, right? 102, and just hit recalculate, 0.5493 equal to 0.5493. And then for outside, it's basically the same thing. Remember to, if you are only doing this, remember to calculate it and input sigma x bar equal to 15 over square root of 32 equal to 2.65165. Use the decimal calculator to do that. So outside of 98 and 102, and so that would be equal to, let's say here, I have to do 98, 102, hit recalculate, 0.4507. 0.4507. So that's how you find them. So anytime you are doing a probability of x bar, remember to adjust the sigma to 15 or to the old sigma of x over square root n. For mean, you don't have to change. Now the second part is very useful in solving problems of a sample of x, sum of all the x. And so in this case, the central limit theorem of sum tells us that the mean of sigma x is n times mu, and the mean of standard deviation of sigma x is sigma times square root n. So you would have to adjust the mean as well as the standard deviation for sum of x. Okay, if you're not finding, because we are trying to find the sum is greater than 34,000. When the mean of x is 100, so every single one of them is around 100 something, but if you have 32 sample size and is 32, then they could be around 3,000, right? So what is the chance that if you add them together, they're greater than 34,000? or less than 34, no, greater than 3,400 or less than 3,400. So the new mean, so you will say mu of sigma x would equal to 100 times 32. And the sigma of sigma x is, sigma of sigma x is kind of funny, 15 times square root of 32. So what is this? We have to calculate this. The first one would be 3,200. The second one, we'll have to use the decimal calculator to find it. Just press 15 times square root of 32. 84.85281. 84.85281. Use more decimal places. So once you do that, then you can do the sigma x greater 3,400. So use above, right? For greater than, we know that it's use above. And the answer would be what? So set this up to 3,200. And this is what? 84.85. I forgot. 281. And then I want above 3,400. See how this is, the mean is 32,000, and I say recalculate. Oh, that is really some more chance of it is so big. 0.0092. 0.0092. What about the chance that the total sum is less than 3,400? So again, mu of sigma x is equal to 3,200, which we have set up already. Sigma of sigma x is 84.85281. We have set it up over here. Is 15 times square root of n. So probability of sigma x is less than 3,400 would be used below. And so use the calculator below, and 3,400, we calculate 9908.9908. The last two is between two numbers as well as outside of two numbers. So because we're using the same mean of x and same standard deviation of x, so our new mean of sigma x it still stays the same, 3,400, and sigma of sigma x would be 84.85281 because it's just 15 times square root of 32. Okay, so for x, sum of x is between two number, between these two number, between 3,000 and 33,000. So we'll use in between. So we just do between 3,000. Is it 32? 32,000. 33,000. 33,000. So we will calculate 0.8807. So it is really, oh, not 300, 3,000. 3,000. Oops, 3,000. Yeah, so it's good to check the graph. 3,000 to 33.8715. And if we want it to be outside, so we would still need to set the new mean. Sigma x is equal to 300 times 32, no, 100 times 32. So it's 3,200. And then sigma of sigma x is 15 times square root of 32. So it's 84.85281. So probability of sigma x is outside of 3090 and 3,400 would equal to what? So that's two particularly 32. Is it 32? No, 3090. 3090 and 3,400. That's really big, right? 3,400. So, but we want it to be outside. So you see this side is really small. This area is really big. Recalculate 0.1066. 0.1066 combined. Okay, so that's how you do the